Hi everyone, my name is Vinay Kumar from College of SVC, Department of Computer Science and Engineering. Today our subject is System Software and Compilers. In that, the topic is problems based on SIC XC program. That is, we need to find counter location count, location counter, and for that location counter we should have to find object code. For that object code we need to write a object program. So first, how to set up a calculator for base mode. For that, in any calculator there will be a mode, two times mode, and that is there will be find a base. In that, press 3. You will be able to now you will be able to done xic sxc problem in base mode. The problem, this is the problem. So for that, first we need to find location counter. For that location counter we need to check whether it is type 1 or type 2 or type 3 or type 4. Given instruction is based on type 1, type 2 or type 3. The type 1 contains 1 byte of size, and type 2 contains 2 byte of size, and type 3 contains 3 byte of size, and type 4 contains 4 byte of size. So firstly, here the operand has been given, that is 1059, and here we need to write for the first location counter, let that as be considered as 1059 only. Here instruction is given as clear and the operand is given as x. X, that means it is a type 2. The registers are considered as type 2, so it is of type 2. And the type 2 means it is, we need to add 2 byte of space to the given counter location, previous counter location. That is, if we add the 2 for the location counter previous one, it will be 105f. For the next one, it has given LDT. LDT is of type 3, so we need to add 3 byte 3 bytes to the previous location counter. That will be 062. And the next one is of also type 3 only. Next is not of type 3 because in the opcode it has given as plus, so we should have to consider as type 4. Okay, if plus is not there, it is type 3. If registers are there, type 2. So consider, be aware of that. And let's move on. It is of type 4, and we need to add 4 bytes, type 4. So we need to add 4 bytes to the previous location counter. That will be 1066. And other, again it is of type 3, so it is the next instruction is of type 3, so type 3, and we need to add 3 bytes of location to the previous location counter, so it is 1069. And the next one is also of type 3 only, so we need to add 3 bytes to the previous location counter. It will be 106c. And again it is also type 3, so the answer is the location counter will be 106f. And now here T is a register, so it is of type 2, so we need to add 2 bytes to the location counter, so it will be 1071. That you should have to do in the calculator, so I'm not using the calculator, I have already done the program. So based on that, I'm writing the answer, so that you should have to do in the calculator. Next is of type 3, so adding 3, it will be, the location counter will be 1074. And next is also for type 3 only, so 1077 will be the location counter. Next is also, next here x05 is considered as type 1 because x is of 4 bits, and 05 is of 4 bits, and total is of 8 bits. 8 bits is equal to 1 byte, so it is of type 1. So it is type 1, and 1 byte only is added to the previous location counter. That will be the location counter will be 1078. Now for the words here as given as 400, so it is of type 3, but here in the opcode they are given as 400, so we need to written like 400 into 3, that is 1200. So the 1200 will be written as in the hexadecimal, that is 4b0. That we should have to add with 1078, and we get 152e will be the next opcode here. 152e will be the opcode for next one, and the last 1015, sorry 1528, it is 28, 28 bit confusion, 28, and here again they have given us 2, so 2 into 3, that is 6. We should have to add 6 for the previous location counter. That will be 152e is the last location counter of the given problem. For this is our procedure for finding the location counter for the given SICXE problem. Now we are moving on to object finding the object code for the given instructions. So the first instruction is of type 2. So the for type 2 we are using this type of opcode format. That is, here we should have to find we should have to take for the opcode first 8 first 8 bits, first 8 in the binary value. First we should have to take first 8 bits of the opcode. That will be, first one is of clear. Clear, for the clear, the bit number is given as b4. The b4 is converted into binary. That will be 10110100. Here we should have to take for the opcode as 8 bits, so we write 8 bits of that 110100. It is of 8 bits, right? So again register, here x value is given as 1, so the binary value of the 1 will be 0001, and register 2 is not there, so 000, and converted into by object code, it will be of b410. That is clear. Next, moving on to LDT. LDT is of type 3, so we are using this object code here. In this, type 3 and type 4 are similar, but the changes with 12 bit 12 displacement and 20 displacement. That's all. The the opcode will be like 6 bits of first first binary values, and followed with n. N is a indirect addressing mode, I is of immediate addressing mode, and X is of index addressing mode, and B base related addressing mode, and P is program counter addressing mode, and E is when it is of type 4 we should have to take 1, when it is type 3 we should have to consider as 0, and for type 3 we take 12 displacements, and type 4 we take 20 address value of the given instruction. So the first opcode is the LDT. LDT, the numeric value is given as LDT 74. For the binary conversion of the 74 will be 1001010. So first six values of the binary value, that will be 100101. And here in the operand, the hash has been used. It means it is in immediate addressing mode, so only immediate addressing mode will be considered as 1, and it is a type 3, so e will be compiled as 0, and all other things will be 0 0 0 0. Here p and b, that is base relative and program relative, also compared as are 0, because it is a immediate addressing mode, so there will be no displacement also, that is also considered as 0 0 0. So the for this, the object code will be 9 5 0 0 0 0 for the other. So this is object for the LDT instruction. Next we are moving to TD instruction. Here you can see place has been used, so it is type 4. So take E as 1 for the first. So next TD is given, the numeric the value of the TD is given as E0. E0, the binary value of the E0 is 11100000. The first 6 bits is, we should have to consider, that is 111000. And again it is a immediate addressing mode, so the I value will be 1, and rest all the things will be 0 0 0. And here the address, it is of type 4, and it has a address 20-bit address, that is, here you can see, here we can see output 1011. Let's consider that 1077. So the object code for this will be, we should have to consider like this, that is E E0, and again 8 1, and rest of the things we should have to write like that only. That is 1077. This is the object for the TD. Oh, there is a mistake. It is of E. E has been written correct only, but it is not 8, it is 1. It is 1, and again 1, and here 01077. So that it will be E11010077. So next moving with JEQ. JEQ has a numeric value of 0330. The bit value, the binary value of 03 is 11110. So we should have to consider 6, so it is only having 5. Add a 0 before the binary value, so that will be considered as 6 bits. And again it is neither indirect addressing mode or immediate addressing mode, so considered as n1 and I also 1, and x is equal to 0. And here we should have to find it is base related or program counter addressing mode, so we should have to consider it as first. So and again is 0. So for first we need to find which is program addressing mode, program counter addressing mode, or base addressing mode. First we need to find program addressing mode, that is PC will be considered as PC is equal to PC is equal to the loop here it is used as in the. So we need to find program counter addressing mode for first, that is loop here we are already used in here. So consider that counter location and minus it with other the next counter location, that is 106 1069. So minusing this we get f9. So f9 is written, and next object code is of ldch. The numeric code for the ldch is 50. So 50 in binary 110010, and we are written like 110106 are there, so 6 are written. And again it is of neither indirect addressing mode or immediate addressing mode. So n and I will value will be 1 1 and x value is 0. And after finding which is base related or program counter addressing mode, we get the value as 00c for the program counter addressing mode. So the value of this, the object code for the object code is CB2 2 and 00C, that is we have written. And rest of the things also same. So using this we should have to find the object code for the rest of the things also. So that is how the procedure to write the object code, and rest of the things I have written already. So this is the object code for the rest of the things. And for this object code we should have to find object program. The object program contains mainly three parts, that is header part, text section, and end session. In header part we should have to first write the program name that is given in the program, that is WRREC, and it should be of 6 bits. So it is of 5 bits only, so I have left the space for the 6 bit also. And next is of counter location counter. So that is of, it is also should be in 6 bits, so I've added two zeros before it. And again the difference between the first location counter and the last location counter, that is if you do that will be commas 0491. And let's move on to text session. In text session we should have to consider first the location counter of the first one, that is I've written here. And the next two sessions I will say later. And here in text session we should have to write every object code that is came and written here, that is we should have to write every object code. And in test session there is only concession of 69 bits only, so it should not exceed than 69. If it exceeds we should have to write another test session for the rest of the object codes. So let's check if it is having 69 or exceeding that. First we should have to consider t 001059, and these two also, that is from till here it contains 1 2 3 4 5 6 7 8 9 9 bits already contained. So we are left with only 60. So that is 4 10 18 26 32 42 52, and rest of the all things we added, i'll get as I'll get as 69. All by adding all this I'll get as 69. So that is 69 66, sorry, 68, 68 I'll get. So 68 is a inner than 69 only, smaller than 69, so we should have to consider as 68. We can write in one text only. Then the two spaces here, 2 as written na, that is the 68 is the 68 as divided with 2, that is 34. That 34 is that 34 is uh, converted into hexadecimal. The answer will be 22. So here, what are the spaces, the size of the text session should be written here. The text session of the 1 byte considers 2 bytes. Two two elements is considered as 1 byte. So we should have to divide it with 2. That's all. That's the thing with that. And next with the end session. End session we have to end with the location counter of the given starting. We have taken now 1059. That should be written as end session. And here I forgot to write this here. This is not object code, but we should have to write here for the end 1059. So that's all the things. Thank you.